Hello everyone, I'm Violetta from University of Adelaide and I'm going to present our work about visual question answering with prior class semantics. Most of the existing VKA models treat the task as a classification problem, where the model needs to choose one answer among a set of fixed possible classes. But this approach has significant drawbacks. When we treat answers just as distinct classes, they are disconnected from their meanings. And so we're losing relations between different answers, and we're also losing the connection between the answer and the question as well, especially when the question already contains the correct answer. To tackle this problem, we introduce a novel method to inject prior knowledge about answers into a model. We supplement a typical classification objective with the regression branch, where we learn a mapping into an answer representation space. This technique can be applied to any classification-based model. It allows us to control the reliance on prior knowledge by balancing the weights of two training objectives. And it also provides a basis for an open set answer prediction. There are two branches in our model. The top one is a traditional scoring model of a predefined candidate answers, and the lower novel branch learns a projection into a semantic answer space. The resulting projection vector P serves to measure pairwise distances between this vector and the pre-trained representations for all candidate answers, which are stored in matrix M. So this matrix serves as a container for external knowledge, and it can be either fixed or fine-tuned during training. We then introduce two losses for two branches respectively. For classification part, we use a typical binary cross-entropy loss. For the regression, we use hinge loss, which makes sure that the learned projection is close to the representation of the ground truth answer, but distinct from the other answers. And the total loss is then the convex combination of these two losses with a weighting parameter. For experiments, we choose Pythia model as a baseline and as a backbone architecture for building our contributions. We also tested a simple approach of knowledge injection, where word vectors are used to initialize classifier weights. And finally, for our approach, we tried three initialization schemes. We used random numbers, shuffled glove vectors, where we randomly shuffle the rows of matrix M, and the normal glove vectors. These ablations allows us to find the real source of improvements, whether it's just a new architecture or suitable values of glove vectors, or actually the exact information carried by glove embeddings. We use GQA dataset for evaluation, and our approach clearly outperforms the baseline and all the ablation studies. Classifier initialization and random values didn't show any improvements as expected. But surprisingly, shuffled glove vectors still gained some improvement, and that's mostly in a binary question category. We think this is because first, answer representations are fine-tuned, so they can still capture relevant information during training. And second is that binary category contains questions with only two plausible answers, which are usually antonyms like yes or no, left or right, and so on. And while the real glove embeddings for such words are quite close to each other, shuffled vectors, due to their random nature, push these representations apart. And so it's easier for the model to distinguish between two possible answers. We also obtained an increase of 1.5% in consistency metrics, and it means that answers produced for the related or entailed questions do not contradict each other, which of course increases the general sanity of the model. So overall, we moved away from the traditional classification approach and reformulated VKA as a multitask problem with additional regressive objective. Then we evaluated our method on GQA dataset and got consistent improvement in accuracy. And finally, we demonstrated that glove vectors indeed carry relevant semantic information about answer words and that they can be used as a simple but effective source of external knowledge. That's all. Thank you for your time and feel free to contact me if you have any further questions.